Okay. Sometimes, depending on what type of polynomial you get, when you multiply polynomials, you'll notice that they create a special product pattern. Now, I'm not real big into memorizing patterns, but if this is a technique that works better for you, by all means go ahead and use it. What I'm going to do here, so as not to confuse anybody, is I'm going to review the special product patterns through problems, but then I'm going to also do the problem in the distributive form as well, so that you can look at both types of problem solving side by side, and you can choose for yourself which one you think would work best for you. So take a good look at these special product patterns and how some of the examples and how they work. You may want to refer back to this chart as we go through the problems, and see if you can follow the actual patterns that are taking place. There's 3 sample problems, and we're going to work all 3 of them, but I'm going to be sure to do all of them in both methods. So let's take a look at what we have here. Sample problem number 5. It says multiply the polynomials. So what I would like you to do is just go ahead and pause the video for each of these before I work them, and try to work them according to the pattern that you see back on the previous page. And then of course, if you don't like that method, you can always work it using the distributive property. But I'll go ahead and do both parts. Go ahead and pause the video at this point and work on seeing if the pattern would work for you. Okay, if we look at sample part A, basically what we've got here is 3x represents the A value and 2 represents the B value. And according to our pattern, if we have different signs, if we have A minus B and A plus B, then our pattern is going to be A squared minus B squared. So it's going to look something like this: 3x squared minus 2 squared. And so 3x representing our A, 2 representing our B. And of course, if I do this, 3x squared is going to give me 9x squared, because you know the 2 goes to both parts. And then 2 squared is 4, so it's minus 4. And so there's our final answer. And of course, if you recognize this, this is what we call a difference of squares. Now, if I were working it in the distributive property method, I would have 3x minus 2 and 3x plus 2. And of course, this would just be a simple FOIL problem since it's 2 binomials. So 3x times 3x is 9x squared. 3x times 2 is a positive 6x. Then we would distribute the other part. Negative 2 times 3 is going to give us negative 6x. Negative 2 times 2 is going to give us negative 4. And of course, the negative 6x and the positive 6x cancel out, leaving us with the same answer of 9x squared minus 4. So we come up with the same answer either way. You have to decide whether you think the distributive property would work best for you, or maybe you'll like the pattern best. Okay, so try that again with part B. Okay, if we look at part B, we have a binomial squared. And so what that means is we have 2 of the same thing. And if you look at your pattern, we have an A and a B. Don't let the actual variable fool you. 5A is representing the whole A value in relation to the pattern that's given to us on the previous chart. And 2 is representing the B value. So in this case, it should be A squared, which is 5A, so we're going to square that, plus, because that's our middle sign, and then we have 2 times A times B, so 2 times A in this case is 5A, and B, which is 2, and then we're going to add that to the B squared. And then we would simply need to simplify the terms, so 5A squared would be 25a squared plus, and then 2 times 5 times 2 is going to give me 20, and then of course we have an a variable in there, and then plus 4. And of course that is the pattern. Now we also have the choice of doing this through the distributive property, and the way we would do that is to first break up our squared term into 2 individual components, and then 5a plus 2 times 5a plus 2, and the distributive property, or FOIL in this case, will give us the following terms, and then we would need to take the following terms and combine like terms, and you can see that we get the same result either way. Okay? Alright, so let's take a look at part C. Part C is quite a bit more complex. We have a cubed term, so we have a cube of a binomial. Well, a cube of a binomial is a little bit more complex from a pattern standpoint, and if you like the other patterns, that's fine. What I'm going to tell you is that the cube of a binomial is a little bit more difficult to remember. You're going to have to work with it quite a bit to commit it to memory, but we're going to go ahead and take a look at it here first, and then we'll look at the distributive property part of it. So if I look at the patterns, I'm dealing with a negative, and so the 2m represents the a, the 3 represents the b, and we're dealing with a negative binomial, so we would look for the pattern with the negative term. So we're going to take the a term, which is 2m, and we're going to raise it to the 3rd power. Now we're going to have minus 3a squared, so we're going to take the 2m and square it, times b, which was the 3, plus 3 times a, and this time we're going to multiply it times the b squared, and then lastly we're going to subtract the b term being cubed. So that's quite a task of remembering that pattern. Now at this point, once we get the pattern in there, then all we have to simply do is to simplify all of the parts. And so we would have 8m cubed minus 3 times 4n squared times 3 plus 3 times 2m times 9 minus 27, and we still have some more simplification to go. So we have 8m cubed minus 36m squared plus 54m minus 27. And that is the final result of the binomial being cubed. Now, that's quite a lot to remember from a pattern standpoint. So what I elect to do most of the time, and what you may choose to do, is to just simply use the distributive property. So since I've run out of room, I'm going to erase this part right here, and I'm going to rework this problem in terms of distribution. Okay, so if we look at this, we have 2m minus 3 to the 3rd, so we can technically write that as 3 individual terms. Now, here's an important part of this. We could simply distribute the first term times the second term, and then after we get that, distribute it to the third term. But what I'm going to recommend is that we group this off and we do it backwards. Let's go ahead and FOIL this second 2 terms first. So I'm just going to rewrite the first 2m minus 3. And then I'm going to FOIL this second group. So 2m times 2m is going to give me 4m squared. 2m times negative 3 is going to give me negative 6, and then of course negative 3 times 2 is going to give me negative 6, so that's going to give me a result of negative 12m in the middle. And then negative 3 times negative 3 is going to give me a positive 9. Now, this is going to make life a little bit easier for us, because now I just have to distribute a binomial over a trinomial. And so what's going to happen here is that I'm going to distribute the 2m times everything first. That's going to give me 8m to the third minus 24m squared plus 18m. Second, I'm going to distribute the negative 3 to everything, which is going to give me negative 12m squared plus 36m minus 27. Now we have a long string of terms, and we just need to combine all of the like terms, which is going to give me 8m to the third minus 36m squared plus 54m minus 27. And if you recall from the previous pattern, when we worked this problem, we came up with the same collection of terms. So you have two choices with each of these. You can either elect to use the patterns for the special pattern, product patterns, or you can simply use the distributive property. I'll let you make that decision.